So what's up? It's Alan Everson again and welcome to another video. So today we're here at chapter 6 network layer and we're going to discuss its summary. So chapter 6 has 5 sublayers following the network layer protocols, routers, configuring a Cisco router, and the last one is in summary. So chapter 6.1, the network layer protocols. The network layer or OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses 4 basic processes. One is addressing end devices, second is encapsulation, third is routing, and lastly, we have the encapsulating. So network layer protocols. Common network layer protocols include IP version 4 or IPv4, and the second one is IP version 6 or IPv6. Legacy network layer protocols include Novel Internetwork Packet Exchange or IPX, AppleTalk Connectionless Network Service or CLNS, DECnet. So IP components, TCP or IP. This is a illustration of TCP IP packets. IP connectionless. It's the illustration of connectionless communication. Best effort delivery. So packets are routed through the network quickly. Some packets may lose and route. As an unreliable network layer protocol, IP does not guarantee that all sent packets will be received. Other protocols manage the process of tracking packets and ensuring their delivery. So IP media independent. IP packets can travel over different media. So this is the encapsulating IP. The network layer adds a header so packets can be routed through complex networks and reach their destination. In TCP IP based networks, the network layer PDU is the IP packet. IPv4 packet header. So this is the content of the IPv4 packet header. So we have this illustration and the IPv4 header fields. So this is the content of IPv4 header fields. Sample IPv4 headers. So as you can see in this picture, we have the sample of IPv4 headers. So limitations of IPv4: IP address depletion, internet routing table expansion, lack of end-to-end connectivity. Introducing IPv6: increased address space, improved packet handling, eliminates the need for NAT, integrated security, 4 billion IPv4 addresses, 340 undecillion IPv6 addresses. Encapsulating IPv6. So, IPv4 and IPv6 headers. So this comparison of IPv4 header and the IPv6 header. IPv6 packet header. So this is the packet header of an IPv6. So this one is a sample of IPv6 header. Routing. Host packet forwarding decision. So the IP address of the R1 interface default gateway address for the PC1 and PC2. As you can see in this illustration. Default gateway. Hosts must maintain their own local routing table to ensure that network layer packets are directed to the correct destination network. So the local table of hosts typically contains direct connection, local network route, and local default route. IPv4 host routing table. So this is the picture here. And the sample IPv6 host routing table. IPv4 rather. So this one is the IPv6 host routing table and router packet forwarding decision. R1 has 3 directly connected networks, and also R1 also has 2 remote networks that it can learn about from R2, and these 10.1.2.0/424. So IPv4 router routing table. So this document that we're using, the show IP route, directly connected routing table entries. Remote network routing table entries. Next, hop address. So the shaded, the highlighted part is the next hop hop address. So routers. A router is a computer. So it's a CPU and router, CPU and OS. So the router memory has RAM, ROM, NVRAM, and flash. So this is the inside of a router. We have different for power supply, shield for WIC, the fan, the SDRAM, NVRAM, CPU, and advanced integration module. So it's the backplane of a router. We have different ports. So the one interface, AUX port, LAN interface, console RJ45, and console USB Type B. It's the serial interfaces and the LAN interface. Cisco OS. The Cisco OS operational details vary on different internet networking devices depending on the device purpose and feature set. However, Cisco OS 4 routers provides the following: addressing, interfaces, routing, security, QoS, and resources management. So this is the bootset files. This is the illustration. Router boot up process. So this is how a router boots up according to this illustration. So the show version output, when you enter this command, will show the version of the Cisco OS software. So Cisco configuring and Cisco configuring a Cisco router. So these 2 steps on configuring a router. We have to enable configure terminal, the enable for privilege exec mode, the configure terminal for global exec mode, the host name, the password, and the password Cisco, login, exit, the line VTUR, and then setting the password, and then encrypting the password, then the banner, and then etc. So configure LAN interfaces. So these are the following syntax that we are using when we are configuring a LAN interface. Verify internet configuration. Interface configuration. So show IP interface brief and ping 209.165.200.226. These are the following commands. Default gateway on a host. So this is the default gateway not needed and default gateway needed. Default gateway on a switch. If the default gateway was not configured on S1, response packets from S1 would not be able to reach the administrator at 192.168.11.10. The administrator would not be able to manage the device remotely. So that's all for today's video, and I hope you learned a lot. Thank you for watching.